Good day, everyone. Welcome to the Certified Math Majors channel. Now, in today's video, I will show you a trick on how to find the higher order derivatives of algebraic functions. So, this is actually one of the tricks in finding the higher order derivatives. There are actually a lot of tricks for higher order derivatives, but this trick applies only to algebraic functions. Now, we'll use the trick in solving the derivatives of these four examples here. But before that, we will have first the uh, rules or the formula on how to find the higher order derivatives of these algebraic functions. So this is the formula. So you have for f of x equals ax to the n, where a is constant, then the rth derivative of the function is equals to a times the permutation of n taken r x raised to the power of n minus r. And then for functions of the form ax plus b, where a and b are constants, then the rth derivative of the function is equals to a to the r times the permutation of n taken r times ax plus b raised to the power of n minus r. So let's use these formulas in finding the derivatives of the given functions here. Let's have the first one. Find the derivative of f of x is equals to x to the fifth. Now going back to the formula, this is of the form ax to the n. So formula is you have a combination of permutation of n taken r raised to the power of x, that's n minus r. Our a is constant, so that's 1, so we don't need to write 1. So let's just have the permutation. N is the exponent, so that's 5, and then the r is the derivative that we're looking for. We're looking for the third derivative, so our r is 3x and then 5 minus 3. Now, when we compute for 5 permutation 3, the answer to that one is actually 60. So this will be 60 x 5 minus 3 2. So the fifth derivative of the function is just equal to 60x squared. Now, the check is left to you, but again, when you check this one, you find the first, second, third derivative, you will eventually come up with 60x squared. Next example, you have find the derivative of x to the seventh minus x cubed. Now, notice that this is fifth derivative and you only have x cubed. So the second term has an exponent which is lesser than the derivative that we are looking for. So obviously, x squared will be gone when we will be looking for the fifth derivative. So by the fifth derivative, we only have to consider x to the seventh. So that would be, the formula is again a times permutation of n taken r x raised to the power of n minus r. A here is 1, so we will just ignore a. So permutation of exponent is 7, that's n, taken r, that's the fifth derivative, then x, that would be 7 minus 5. So now the fifth derivative of the function will now be equal to permutation of 7 taken 5 is equals to 2520 and x raised to the power of 2. So this is the answer. Next example, you have fifth derivative of 3x to the seventh. So again, formula is you have a permutation of n taken r x raised to the power of n minus r. Our a now is 3, so we will just have to write 3. Then this is permutation of 7 taken 5, then x, then n is 7 minus r is 5. So now we have the fifth derivative of x. You have this one here, 3 permutation of 7 taken 5, that's 2520. Then this is x squared, so this will give you 3 times 2520. This is 7560 x squared, and that is now your answer. Next, this derivative here, the last one, last example, you have derivative of third derivative of f of x equals 2x plus 3 raised to the power of 4. So this now has the form of ax plus b to the n. So the derivative will be a to the r times permutation of n taken r times ax plus b raised to the power of n minus r. So, third derivative, our a here is 2. So, this will be 2. Then, n is the exponent. So, that's 2 to the fourth. And then, permutation of 4. Then, the derivative that we're taking is 3. Then, ax plus b, that's just 2x plus 3. And then 4, that's 4 minus 3. So now you have 2 to the fourth is 16. Then permutation of 4 taken 3. Then you have 2x plus 3. 4 minus 3 is 1. So this will now be equal to, if you take 4 permutation 3, multiply it by 16, that will give you 192 times 2x plus 3. So this now is our third derivative, or the f triple prime of x. So that is now our answer. So that's all for this video. Please subscribe to our channel to keep you updated on our next videos. Thank you so much for watching and enjoy learning.